So in this video, we just want to take a little bit of time to show some of the applications of missing portions of right triangles. So if you look at this first example, this one is about as cut and dry as it can get. It's already provided to you. There's no context here. They give you the triangle. They label the angles with capital letters, and that's something that's pretty commonly done within trigonometry. And they label the sides with the lowercase letters. What you will notice is you'll notice that each letter is being used as both an uppercase and a lowercase. So if you look at angle R, which measures 90 degrees, the side that corresponds to angle R is actually across from it on the other side. And that's the same thing with capital angle Q and side Q and capital angle P and side P. And that's a common convention. That'll be used quite a bit when you get to the point where you're doing some work with the law of sines and the law of cosines before your trigonometry unit is going to come to a close. But in this particular problem here, what we want to do is we want to try to figure out what the length of side Q is. So we want to know this. We don't know the length of side P. We do know that side R measures 14 units. We do know that this is a 90-degree angle, but really the 90-degree angle is basically just providing us with the green light to use sine, cosine, and tangent. Those ratios apply to right triangles. The fact that this is a right angle gives us the green light to go ahead and try to use something from what I have written here is SOHCAHTOA, and so that's a pretty commonly used way to try to remember the sine, cosine, and tangent ratios. So you'll notice I highlighted three things: the side that we want, the side that we knew, and the angle that we knew that was not the 90-degree angle. So what I need to try to do is I need to try to figure out which components from SOHCAHTOA are going to be most useful to me within this particular situation. And this is going to be something that changes from problem to problem. So I know that I have to base everything off of this 35-degree angle. So I need to ask myself how the side that I want, side Q, and the side that I know, side R, how these two sides are related to angle P, which measures 35 degrees. Are they the opposite, the adjacent, or the hypotenuse of the right triangle? So I always start by identifying the hypotenuse. The hypotenuse is always the longest side. Hypotenuse is always across from the right angle. This is the hypotenuse, right? Side R is definitely the hypotenuse of this triangle. How about side Q, the side that we want to know? Is it the adjacent leg relative to this angle, or is it the opposite leg relative to this angle? So adjacent means along or next to, and this side Q is definitely along the angle that is 35 degrees, and it is clearly not the hypotenuse of the right triangle. The hypotenuse is that longest side across the bottom. We've already identified that. The side that we want to find is the adjacent leg relative to the 35-degree angle. So if we think about what we just said, we have the hypotenuse. We want to know the adjacent leg to the 35-degree angle. So if we have H and A, hypotenuse and adjacent, which of the pieces of SOHCAHTOA involves those two components? And it's that middle syllable, CAH. And that middle syllable is CAH because the cosine ratio is equal to the adjacent leg divided by the hypotenuse. And so if you look at what I set up here, don't look at this 4 times 14 just yet. I have cosine because we have adjacent and hypotenuse related between what we knew and what we wanted to know. So I have cosine of the angle that we based everything off. Cosine of 35 degrees equals adjacent. Well, adjacent to the 35-degree angle, we had side Q. So you see I put that in the top of the fraction, and then divided by hypotenuse. So cosine is equal to adjacent divided by hypotenuse. Adjacent is Q. Hypotenuse is 14. What I need to do is I need to solve for Q. So the way that I'm going to undo this division here, you see it's already been done. I'm going to multiply both sides by 14. So that's actually where this times 14 came from. Because when I multiply by 14, these cancel out into a 1. So I'm just left with Q. And then what I can do is I can go to my calculator and I can type in 14 times cosine of 35. Now, what you're going to need to make sure you do is double check the mode on your calculator. We're still early on in our discussion of trigonometry. There are two different ways to measure angles. We are measuring right now exclusively in degrees. So if you type 14 times cosine of 35 into your calculator and you do not get this answer, it very likely means that your calculator is measuring in radian mode rather than degree mode. So hit the mode button, make sure that you see DEG or degree as the mode that your angles are being measured with, and you should be in pretty good shape. So in the next few videos, we're going to ramp it up a little bit. What we're going to be doing is we're going to be doing some problems where we are actually going to be responsible for eventually drawing the triangle and trying to identify through a story problem what we have and what we want. And so those are a little bit tougher than what we did initially here, but this is, the type of introductory trigonometry problem that you can expect to see right when you start applying SOHCAHTOA, right when you start applying the sine, cosine, and tangent ratios to find missing sides of triangles. I guess the last thing I want to say about this video before we close it out, I could have gotten the same answer a different way. I know that this 90-degree angle and this 35-degree angle have to add together with this blank angle, this angle Q, to get to 180 degrees, right? The sum of all of the interior angles of a triangle has to be 180. So if I took 180 and I subtracted off 35 and I subtracted off 90, I would then know what this side right here is. I could have done a similar setup based on side angle Q. I would have been using a different trigonometry ratio because I would have been dealing with a different angle then. So I would have had to use the appropriate piece. And I think if I was dealing with this, this would be the opposite side to this blank angle, angle Q, and this would be the hypotenuse. So opposite and hypotenuse would involve the sine ratio. So the nice thing about trig is that there's a lot of flexibility. You can use multiple ratios a lot of the time because as long as you know an angle and at least one of the sides of a right triangle, you're going to be able to use SOHCAHTOA, use the fact that all of the angles add up to 180 degrees. If you know two of the three sides, that opens up for the opportunity to also use the Pythagorean theorem. You've got all of those things in your toolbox at this point, and they can all be used with each other in order to find missing components of right triangles.